Let's go over some multiple choice questions about the prep step of cellular respiration. Before we get into the questions, let's just quickly review this step. Remember that this step is going to take pyruvate and convert it into something called acetyl-CoA. And this occurs in the matrix of the mitochondria. One thing that's going to happen during this reaction is NAD is going to become the high energy molecule of NADH. This is going to be a transporter of electrons that's going to take the electrons down to the electron transport chain. This is the first step where we're also going to produce CO2. Each of these 3-carbon pyruvate molecules is going to get broken down and give off one of these CO2 molecules. So in this step, the pyruvate gets changed into acetyl-CoA and it's going to produce CO2 as a byproduct. One last thing is to remember that we get 2 pyruvates from glycolysis. That means we're going to make 2 acetyl-CoAs. They're going to go into the Krebs cycle. Here's our first question. How many carbon atoms are fed into the citric acid cycle, so that's the next step, as a result of the oxidation of one molecule of pyruvate? This is already a difficult question, maybe a little bit harder than an easy question, but the actual question's pretty easy. Let's figure out why. Well, it's just asking how many carbons does the Krebs cycle get from pyruvate breaking down? So again, we only have one pyruvate. Remember that it starts out with 3 carbons. The prep step is going to break down that pyruvate and make it into something called acetyl-CoA, which only has 2 carbons. So for every pyruvate molecule, we're only giving the Krebs cycle 2 carbons. Even though technically we do get 2 pyruvates and we're going to give 2 acetyl-CoAs to the Krebs cycle, we're only talking about 1 pyruvate. So 1 pyruvate breaks down, it's oxidized, it's going to become a 2-carbon molecule that's fed into the Krebs cycle, which means A is the correct answer. Here's the medium question. The conversion of pyruvate to acetyl-CoA produces which of the 2 following? So looking at our answers, we can automatically scratch out A and scratch out C. We don't produce ATP at this step. So we're now down to a 1 in 3 chance. Yes, we produce CO2. Yes, we produce NADH. I think that's the answer, but let's go and double check. NADPH, no, we produce that during photosynthesis, so that can't be right. NADH and FADH2, that would be right if it was for the Krebs cycle, not the prep step, so this isn't right. The answer here is B. Here's our last one, the hard one. Prior to entering the Krebs cycle, each pyruvate molecule loses electrons, hydrogen ions, and a carbon, forming an energy-rich molecule of blank. So this is a hard question only because there's a lot of words in this first question here. There's a lot of things going on. Talking about hydrogen ions, pyruvate, molecules losing electrons, carbon, it doesn't specifically say, but this is CO2. Again, confusing. Basically what all this question's asking, what's the energy-rich molecule that the prep step makes? That's NADH. NADH is going to hold that energy until it delivers it down to the electron transport chain. So this question might have a lot of words, but the word that you have to really focus on is energy-rich molecule. That's NADH.